Today in this video we are going to show you the 3-point bending test or the flexural test on the two samples, that is the glass fiber reinforced composites and another one is the wood. Okay, so this glass fiber reinforced composite is having the thickness of 0.5 mm. You can see, sorry, 5 mm. The thickness of this is 4.96. So this is 5 mm of thickness. So we are going to use the L by T ratio 16. So our length will be 16 into of 5, that is 90 mm. And the span we are taking the 10% on the each side. 10% of the length on the each side. So to start the test we have to fix the fixtures. So this is a Tinius Olsen machine. This is the cross head. This is the load cell. We are going to put the top roller. We have to match this hole with the hole here. We have matched it, and then we have to put the direction so that you understand. This is the lower fixture. We are going to put it here on the lower side. So we have put it on the lower side, and now while keeping the sample here, the roller should touch here, so we have to rotate it. We rotate it, then we are fixing it here. We are not tightening it just because we have to check the alignment. How we are going to check the alignment? First you can see this is moving here and there, so we have to tighten these rollers here. I am not tightening too much because I have to align this and I have to see whether it is a straight or not. So these are the first button to switch on the machine. These are the two buttons to move this cross head or the jogs up and down. We are moving it by double clicking so that it will move fast. Now I am pressing it single so that it will come slowly so that I can match it. So I have loosened it slowly and I am now going to match it, whether it is aligned or not. Now I can see that it has aligned perfectly. So I am going to tighten it here. Tight means it should not move. It should not have any kind of movement or vibration, but not too much tight. The lower portion even you can tighten it, but top one is having the load cell, so avoid to tighten too much. Yes, it is perfectly aligned, so I am moving it up. So I have already told you the thickness of this is 5 mm. For the thickness of 5 mm of samples, we have to move these rollers so that the length is 90 mm. So we already have the marking here, but we are using our own scale and making it at 90. From the center, 45 mm on the both sides. Okay, so at the starting I have told you this, the length between these two rollers is called the span length, and the extra part which is out of this roller is called the overhang length. So we have marked on the samples that you can see it from here, that is we have marked, or I can show you again. This is the sample that you can see, we have marked it at 90 mm for the span length. The extra part is the overhang that will be outer there from the rollers. This you have to place it at center, and now I am moving it slowly downward. Now the remaining movement I will do with the software. So this is a Tinius Olsen software. So first of all we have to go in the tab option. In the tab option we are going to use the D790 Flexural string, D790 ASTM. So that is already selected here, otherwise we have to change the method here. I am saying okay, and you can see the current output is ASTM D790. Then we are going in the method editor. In method editor there are the source selection, that is which output we are going to want. Okay, the parameters. In parameters I have to mention which type of sample is there. Already mentioned, it is a flat and it will move the fixture cross-head will move in the compression, will move downward. Entries. In the entries, which dimensions I have to put? I have to put the width. The width is the 13 mm, that is the standard. Thickness is 4.95. The length, that is the the length is 90. The support span is also, that is actually we are putting the 90. Actually in the length I have to put 108. That is 10% of each side, but support span is 90 mm. I am going to put the save. Now data importing control segment. Control segment is very important. Here I am using the 1 mm per minute of crosshead displacement, that is the rate of position. And what is the end condition? In the end conditions I am putting value reaches the end. Okay, but I am saying here specimen break. Whenever the specimen will break, my testing will stop. I am going to save. In output editor I am going here for data exporting, file information, browse, going in desktop and saving it. GFRP V2. I am going to save. In output editor you will see the live data, which live data you want to see it there, which results limit, graphing. In graph, how you are going to want to see the, means to say what will be the output of our force versus position, 50 Newton of gaps or 10 Newton of gaps in the y-axis. Whatever you want you can come and change here, the length, name, anything you can come and change it. So we have already saved it. We are coming back, test and recall. here we are going to make it 0. Now we are moving this jog downward, slow. This is a slow jogs, this is a high speed jogs movement. So this is a slow moving jog, so which we are moving downward. When we made it 0, then we will come to know here it is minus 7 Newton force has came. So I am just moving it little bit upward. Okay, minus 2 Newton I am giving the preload and making it 0. Now I am coming here and I am saying reset. Yes. Now I am going to start the test. I am saying start the test. Here you can see force position graph has started to come. Now our focus is on the testing, how it will be behaved. So we are showing you the testing.
Oh, this is Upatesha notes, huh?
So friend, there is a drop in the curve has occurred. Okay, this drop in the curve, so that we are going to stop the test here. So we are stopping the test here because there is a drop in the curve.